Good morning, one and all, to the day 4 of a 5-day online faculty development program on blockchain technology, being organized by Bangalore Institute of Technology in association with AICT Training and Learning Academy. I thank Dr. Manik Das for getting associated with this faculty development program. Thank you, sir. Giving an introduction to Dr. Manik Das, he's a professor of computer science at the Dhirubhai Ambani Institute of Information and Communication Technology, Gandhinagar, India. He received his PhD degree from Indian Institute of Technology, Bombay, and MTech degree from Indian Institute of Technology, formerly ISM, Dhanbad, India. He has over 22 years of research and teaching experience in information security and information technology. His research work broadly covers all areas of cybersecurity and IT security management. During his professional service, he has served as investigator of several sponsored research projects with national and international collaborators in the area of security and privacy. He is currently on editorial board of IEEE Transactions on Dependable and Secure Computing. He has served as a member of the Technical Program Committee for many international conferences and workshops. And he is a regular reviewer of IEEE, ACM, Springer, Elsevier journals. He is a senior member of the IEEE and life member of Cryptology Research Society of India. Sir, it's an honor and privilege that you have accepted to be a part of this program, sir. I welcome you. I heartily welcome you, sir.
Thank you, Professor, for the nice introduction. First of all, good morning to all participants, faculty members, research scholars in this event. And thank you for involving me in this event and allowing me to share my knowledge, experience with all these participants. So next 1.5 hours, I'll be with all of you, and let me see how much I can share my knowledge with all of you, but don't focus on that lecture slide, whatever I'll run through this session. Whenever you have any doubt, any questions, feel free to stop me and ask. So that will be much more interactive session, which will be useful for all of us. So allow me to share my slide. Give me a moment. Please confirm me if the screen is visible.
Yes, sir. It's visible, sir.
Yeah. All right. So the title is very generic, blockchain and reductible blockchain, and some challenges and some opportunities that I thought to share with all of you. Since it is the 4th day of this event, so I believe some of the terms which I will use will be repetitive in nature, because you have gone through 3 days, 3 days of this event. So there may be some repetition, but I want to basically create that necessary background, and then we'll bring the issues and challenges which are currently being explored by research community, and in future that applications which will rely on blockchain, this disruptive technologies. Okay, so perspective of blockchain and reductible blockchain, issues and opportunities. So this blockchain is basically nothing new. That blockchain and also it is not a magic stick that it is going to change everything in a new form. Nothing new or not a magic stick. So basically, very nicely that concept structure, data structure, and with that structure, as a say well thought out of features which have been captured in this blockchain technologies. And before Satoshi Nakamoto, 2008, this structure was also there. People, research community, they have realized this structure, but the success story of this structure or blockchain was greatly influenced by that popular cryptocurrency Bitcoin or Bitcoin blockchain. Okay. Let me just quickly create the background because I want to make my session as self-content, self-sufficient. So what you can see that this is the notion or where we basically we can see that how blockchain or what is that exactly. Okay, a textbook or literature always one can refer, but the notion is basically it is already there. That is what before 2008 that blockchain structure or notion was already there. So if we agree on history, and history is very essential asset, so always we refer to history. If we agree on history, then we agree on the present state of the world. So current state, we can establish or we can agree on the current state, present status of our society based on the past facts or based on the history. So always we refer to history. Then we endorse the current state and then again move forward. So if we agree on history, then we agree on the present state of the world. And a blockchain, what it does, blockchain lets mutually participating entities agree on history or transaction. In blockchain, we say that it is transaction. Blocks or set of transactions. The blockchain lets mutually participating entities agree on history or transactions, which lets them agree on the current state of the system. The blockchain, again, it is basically moving forward based on that previous set of transaction or previous set of blocks. Then it creates a current transaction, then it creates current block and agree on the current block, then it moves forward. So again, it relies on that fact, the first fact. If we agree, that means if all that miners or participants in that blockchain, if they agree on history of that blocks, transactions, then based on that, they agree on the current state of the transaction. Then they create the current block. Okay, so that fact follows blockchain. Blockchain follows the same fact. Now, then simply we can visualize blockchain by this line. That start state, there must be a start state. Or in Bitcoin, that start state is known as Genesis block. So there must be a start state, then history of transactions or set of blocks. What do we say that? Chain of blocks. Start state, then history of all transactions. That will give us the current state. So to create the current state or current block, we have to have that all previous blocks in picture and importantly that Genesis block or start block. Then combinedly, we can endorse the current state or current block. And then next block, next block, next block. So that is the notion behind of this structure or this blockchain technology. The start state plus history of all transactions will give us the current state. And if we agree on the current state, then that block is created and we can go to the next block. Okay, so if we remember this, then we can easily define what is basically that ledger, or what is that blockchain, or what other variants of that different kinds of blockchains. But important thing is that left hand side, there must be a genesis block or start block, start state. There must be chain of blocks or history of transactions. And then we basically create the current state or current block. And if we agree on that current block, then that is created, that is captured in that history part, and next block will come. Let me bring a context into the picture. Okay, and no need to just look at Bitcoin, cryptocurrencies, because blockchain is a structure, then very nicely thought out of structure, which can find different applications in different that context. Just bring one context, you can identify several contexts. Playing chess over email. So nowadays everything is online, so we cannot sit face to face, but we can play chess over internet, and we are basically accustomed to do most of the things over internet in last 8 months, 7 months during this pandemic crisis. So if we plan to play chess via email, then you see that how that blockchain, that structure or that technology can be captured in that chess playing game. Each of line is one move in the game. That is perfect. So 2 players, Alice and Bob. Alice first move, then Bob first move, then obviously Alice second move, then Bob second move, then Alice third move, Bob third move, and continue. But what is agreement in this game? So no backtracking. So after third move, then Alice may not be allowed to go back to the first move or second move. Similarly, Bob. So it is basically forward moving game, and backtracking is not allowed. That means changing the previous move is not allowed. And blockchain also does the same thing. Once you commit, then that is captured in that previous block, in previous that set of transactions, or that is captured in history, and history cannot be changed. Right? So here you see that we are not allowing that history or past that commitment, past transactions. So whatever move has been done, that is captured. And next state, next state, next state, and next state. So continue. So we can easily bring similar context into blockchain, that technology or applications of blockchain. Now, what's that got to do with blockchain? Again, that same line, start state, history of transaction, or start state plus history gives us the current state. For start block, then history of blocks gives us the current block. Now, what's that got to do with blockchain? We all agree on the initial state of the game. Initial state of the game, after that toss, Alice was allowed to move first, then Bob, then Alice, then Bob, then Alice, then move. That was the initial state of the game. Then we all agree on the current state of the game. We'll all agree on the current state of the game, and this is the rule of the game. Altering previous state is not allowed. Or history is not going to be changed. History will be intact in that game. So altering previous state is not allowed. Then again, to the next level in blockchain technology, what exactly is our objective in blockchain technology or in that game? So we want a consensus. We want a consensus among all the participants in that game, among all the participants in that blockchain application. The consensus is required. What it says, we all agree on the initial state of the game. And similarly, that consensus will be required in any other block. But in initial start of the game, initial state, again that consensus is required. Again, next block, that consensus will be required. So consensus is one of the important features captured in that blockchain technology. Then next, transparency. So we all agree on the current state of the game. So that execution of current transaction or current state is done in a transparent manner. So Alice, then Bob, Alice, then Bob, Alice, then Bob, Alice, then Bob. So there is no hidden factor. Again, executing the transaction, so there will be consensus among all the participants, and that will be acceptable to all other participants. Then they agree in a transparent manner that, okay, this transaction is now locked in that blockchain technology. Okay. Now, next is altering previous state is not allowed. Altering previous state is not allowed. So history cannot be changed. History cannot be changed. That means altering previous state is not allowed. So again, that is very important, that we will not allow that history be changed by any that powerful or any other participants. So that is not allowed. So this consensus, transparency, and immutability, that I is immutability feature, the altering previous state is not allowed. So these three features are essential features in so-called blockchain technology. Okay. Now, just look at this and just see what it says, that textbook definition of blockchain. That what is blockchain? Just look at this and try to understand and tell me if it is clear or not. Or if you have any questions, that whether you can justify this, that blockchain are distributed ledger that keeps all previous states intact. It is a distributed ledger. Now you need to ask question, why it is distributed ledger and that keeps all previous states intact. That means history must be intact. We will not allow altering any previous transaction, any previous blocks. And why it is distributed? Because we have to have consensus and we have to execute all that execution, or we have to consider that transaction in a transparent way. So this line, a distributed ledger that keeps all previous states intact, essentially carries these three features: consensus, transparency, and immutability. An important thing that you must note down, that this is only append only structure. Only you can add append only structure. So this structure, if you recall that most of the classical data structures, any classical data structure, then you will see that that data structure will allow add, delete, modify all these features. You can add a new node, you can delete any existing node, you can modify some of the nodes in that structure. But this blockchain that what we are familiar with, including Bitcoin and other similar blockchain, so these blockchains are append-only structure. Okay, so that is one important that note. So I will come back to this append-only structure sometime later. So this structure allows create, add, view. So no deletion, no alteration. Okay. Important thing is that structure doesn't allow delete and modify of the records, and that is the notion of that Bitcoin blockchain and similar other blockchain. So immutability feature, so you cannot delete and you cannot modify. So only append, create, add based on consensus, and if any requirement, then you can view the records. Okay, maybe you have gone through this that primitive or this term. So that is blockchain. That means it is a tamper resistant.
So you're not audible?
Connect
So
different
audible,
blocks,
sir.
then you create this. Hello.
Yes, sir. Now we are audible, sir. You were not audible for.
Okay. Okay.
Yeah. Yeah.
Okay, so basically, you see that this is. I hope you have gone through this that basic part in previous 3 days. So this is the blockchain, and important. Now, who is playing role here in this tamper resistance? Here it is that a hash function. Okay, now that is basically allowing us to go with that tamper resistance property. There are several cryptographic primitives as algorithms. SHA-256 is being considered in several that blockchains. An important thing is that this is the record. So this is the digest of the record as value. Then one can verify that digest with the digest and captured digest. If both match, then that record has not been altered, or that integrity of that data is established. If any mismatch, a single bit mismatch, then we say that it is tampered with. Now, if somebody is altering, in any other block, if somebody is altering, then you see that this red highlighted part is an altered block of data. So in that case, all previous blocks or previous that history before that block will remain as it is. But important thing is that the subsequent blocks will get modified, because this next block, that hash pointer, that HP block hash pointer, which has address of the data and hash of the data, that is hash pointer. That hash pointer, it contains that previous block digest. Now previous block digest, if previous block is changed, then this hash pointer of the block will get changed. and all subsequent blocks after this tampered block will get changed, and that will basically give us that it will lose that feature consensus. That consensus, if somebody is altering here, then this block, that hash pointer will be different, and that will go against that consensus of that previous hash pointer. So all subsequent blocks will get changed. So we cannot modify any previous block, because if we modify, then after that block, whatever blocks or whatever transaction got executed will be different. Okay. Again, that hash algorithm is playing important role, and in particular, apart from that hash algorithm, one interesting structure, that is a tree structure, Merkle tree, is basically playing role in this structure, and Merkle tree is essentially using that hash algorithm. And Merkle tree is playing in one kind of blockchain. Similarly, that Merkle Patricia tree is using in another blockchain. So ultimately, that structure, that classical data structures with some new features are bringing that interesting property into this blockchain structure. Then we can again go with that three properties: consensus, transparency, and immutability. So this immutability feature, we cannot modify any block in between, because subsequent blocks will be different if we do so. Okay, any questions from participants? If any questions, you can ask me now. Otherwise, I'll go to the next part of the presentation.
Actually, they are all in mute mode, sir. You want me to unmute, give them an unmute option to ask question?
Okay, if you have that pattern, that end of the presentation, we can unmute. Fine. Otherwise, if any questions, I can take a question in between also. Otherwise, I can proceed with my that presentation.
Okay.
Okay. You can note down all the questions, queries. I can take last 10 minutes or so. I can take any questions from audience.
Excuse me, sir.
Yeah, please.
There are different consensus algorithms, like a proof of work we have heard, but there are so many other, like a POS, proof of stake, and proof of importance. So can you just highlight them on them, sir?
Yeah, good
Just
questions. Good question. I got this. Very good questions, and one that prominent research problem, that consensus algorithm, and nowadays that smart consensus algorithm is a demand in industry. So proof of work, that Bitcoin, you can have the idea of proof of work. So basically a puzzle solving, that is proof of work in Bitcoin. You have to solve a puzzle that has algorithm. Some string will be given, and you have to find some remaining string. Then Ethereum and other variants, say proof of stake, means how much ownership basically one has. Based on that, importance will be given. Okay, so proof of stake, then proof of resource or space, that computational, that proof of work is basically computational, that time is the factor, computational time is a factor. Then opposed to that proof of work, that proof of space, because we have more memory nowadays. So how much space one can invest and how much space one can utilize to, again, to find a consensus. Basically, ultimately, it is a consensus, whether proof of work or whether you're solving any puzzle, or finally you have to arrive at a consensus. So that consensus may be arrived with the help of that's availability of space, and may be arrived with the stake, how much stake you own from that particular application. Then say there are several other, that how much share one can have in that particular application. So that consensus algorithm, basically you have to have an agreement with all the participants on board, so you can basically establish your proof that you have done the job, whether it is solving the puzzle or it is executing that transaction, and then you can basically, others will accept that part, whether it is stake, whether it is based on space, based on the value or ownership. So all these logic are important, but these will vary from application to application. So from one application, you can go by that proof of stake, another application that proof of space. For example, if we bring the context, say, suppose supply chain, that application, then proof of stake may be more appropriate compared to proof of space, because that stake, whether municipality or farmer or that middle person, that stake can be distributed, or stake is going to be acceptable by different participants involved in that particular application. Then healthcare application, again, you can have a different kind of consensus algorithm. Cryptocurrency, proof of work kind of that notion is very useful, because there is another factor, that if somebody is solving that particular problem, then you will reward, you will give some incentive. So you bring more people to solve that particular problem. But in another application where you may not invite all participants, or in other words, you may not place your application or that blockchain as a public ledger. It can be say that in between public and private. Some people who will have stake, they will have say. Other people will not have any say. So application to application, that consensus algorithm may vary, but ultimate objective is that there should be a logic, there should be a contract which will be agreed upon by, you say, whether important stakeholder or participants, or by all the participants. That is the important logic. So there will be a contract, and that contract is going to be endorsed by the intended participants in that particular application. One important research problem, and people are basically coming up with different kind of that consensus algorithm, and that may go by different that logic, stake, space, then money, share. All these are basically coming into the picture, but notion follows that same. Whether you will bring time into factor, or you will bring that resource into factor, or you will bring money or that people power into the factor. So based on that will basically work out on given application. So one consensus algorithm may not fit to all applications. Given application, one may really justify that, okay, yes, this is the consensus algorithm, which is more appropriate than that classical consensus algorithm.
Okay, sir. Thank you very much for making the things very clear, sir. So one more related question I'm having. So you talked about the time, resource, and these are the factors. Suppose I want to assign some weightages, like 75% I want to give the weightage to the time and 25% to resources. Like that, we can have the combination of, or strictly have to select one consensus algorithm.
You can, but important thing is that there are three parameters: consensus, transparency, and immutability.
And even the custom
without diluting or without bypassing these three essential features.
Okay.
We have to basically convince the stakeholder or the target participants in that particular application. Then that job will do. We can come up with some consensus algorithm, but without diluting that those three essential features.
Okay, sir. Thank you very much.
Okay, let me run through some more slides. Then I can give a pause, and you can ask some more questions. So some myths. And it is factual. That myth one: blockchain is a magical database. It is not a magic. It cannot change overnight any application. We have to use this structure, this technology, in a convincing way for existing applications. That is the objective. Okay, and Bitcoin, that success story is very visible, and behind of that success story is that one feature that I am convinced is that incentive model, or that rewarding. That incentive model was very beautiful. That feature considered by that inventor of Bitcoin, Satoshi Nakamoto, a group of people. So that incentive model basically made Bitcoin is so success, right? And other things, that structure you can see: append only structure, tree structure, Merkle tree, linked list, then hash functions. All these were basically there in literature in several decades. But incentive model in Bitcoin is a very nice idea behind that success story. So blockchain is not a magic stick. And second myth is blockchain is going to change the world. I don't think so. We have to use this blockchain for different applications, and we have to basically optimize the resource and improve or enhance the efficiency of the applications, and finally improve the revenue which will be earned from that application. For that, we can use the blockchain technology. Third myth: there is only one blockchain. I believe all of you are aware now. So there are many blockchain. So Bitcoin is one of them, Ethereum, then other different platforms. You have several blockchains now in literature. Fourth myth: blockchain can be used for everything. We have to see where it has scope, and we can bring that structure into the picture. Blindly, we cannot say that, okay, it can be used for everything. Right? So that is very simplified statement, but it may or it may not. Then fifth myth: blockchain can solve all problems. May not be true. It can help us to solve different problems, but it cannot change the entire world, or it cannot solve all the problems. Then next myth: blockchain is secure, cannot be hacked. Not true. Even in Bitcoin, that got hacked several times, and people have lost huge money from that hack, and several So that security or secure, it is basically, it should come from the confidence. And if that confidence is loosely thought out, then it is not secure. If that confidence is provided with all that groundwork in place, then that confidence or that belief will be factual. Otherwise, people can say that, okay, it is secure, you can use, but it may be insecure, say after a week time, and people can hack that part. Ultimately, it is a digital distributed ledger, and if bad people can get into that ledger, can manipulate. Similarly, there are several myths. Okay. Now you can see applications in all sectors. We can apply blockchain technology, digital currency, record keeping, then securities, smart contracts, record keeping. Several that stakeholders, government, they have started utilizing these blockchain technologies for land record, then other property related. So those things can be captured here. Digital currency, very successful. Then digital rights, insurance, identity management. There also we can find blockchain technology application. Then securities, crowdfunding, derivatives, etc. Here also we can find. But you can ask one question to yourself, and I also ask that same question to myself. If it is so, then why people are taking time? Because we can see success story of Bitcoin, we can see success story of that Uber and other thing. We can see the success story of that Ripple, and why that this record keeping, then this insurance, smart contracts, supply chain are not very, very visible, which are empowered by blockchain technology. What I understand, that solution is in place. That solution, for example, supply chain, that solution, that shipping is a big supply chain, that vehicle, shipping that area. So supply chain is powered by blockchain. Solution exists. Solution is available in different industries. But ultimately, we have to see that customers' convenience, and important thing is that its acceptability in different countries, right? So if we send a ship from our country to a country X, if X is not convinced about this blockchain, or if their regulatory norms do not comply with blockchain, then we are having solution at our end, but on the other end, that compatibility issues is a big issue. So unless that different countries, continent, so unless they have that consensus, they have that uniform regulatory norms which will be compatible with this blockchain technology, even though solution is there, but we are not able to sell that solution to others. And Bitcoin, no one is owner, everybody is owner, that Bitcoin. So there is no need to have that compatibility into the picture. There is no need to have that different countries consensus into the picture. So it is free for all. And that is the difference between, you can position that why Bitcoin, that solution is very, very success, and why other solutions, even though they are ready by different industries, still we are not able to see that success which will be comparable to that Bitcoin, Ripple, and so. So here basically agreement, compatibility, ownership, all these are critical things, and people are basically discussing, negotiating among themselves. Maybe in future we can see different applications which will be very, very successful and which will be supported by this disruptive technology blockchain. And government municipalities, they are basically using this blockchain technology for record keeping, and that will be a reality soon. In different countries, they have already done. In our country also, various agencies, government authorities, they are going to have this record keeping, which will be supported, powered by blockchain technology, and we will be witness to this part. Okay, so maybe you have gone through different applications. I will not spend much time on this. I will just move to that important part of my session, that is whether we are happy with this blockchain, only these three features, that consensus, transparency, and immutability, or we are not happy, or application needs some tweaking, or application needs something more. Now, points to ponder here. Consensus, yes, we have to have consensus because it has to be acceptable by all the participants in that application. Consensus we have to have. Transparency, always good transparency. Right? So everything, if we say that it is transparent, then we are not going to lose anything. But if we say that it is not transparent, then people will ask questions. So always this is an important factor. Unlinkability required, but not for all the applications. For some applications, unlinkability is required, particularly cryptocurrencies, because the notion is that when that 100 rupees, that currency moves from your wallet to your friend wallet, then moment it is in your friend wallet, then your friend is the owner, and your friends will not be able to tell from which source that 100 rupees currency came to his or her wallet. So there is no link. I have some currencies in my wallet, but I cannot tell before my wallet who was the source of that currency note. So I cannot link. Okay, and anonymity is required in different applications, but not for all applications. Integrity, immutability, it is required because history should not be changed. Okay, but you see that in our practical scenario, sometimes people come strongly that okay, that particular history was captured wrongly. We have to change our history, right? And history can be rewritten. It is not a new word, right? If something found erroneous, if something is convinced to the entire society that yes, that was an error, then instead of going by with that error, it is always advisable to rectify the error. And since all these transactions, all these blocks, all these contracts are agreed upon by who? By human. And we cannot say that, oh, I cannot do any error, I cannot do any mistake. So there may be some mistake, and if that mistake is visible to everybody, then that mistake can be say tuned, mistake can be rectified, and that is always, that will have always merit in that particular application. So integrity and immutability, whether it is true for all applications, or there are applications where we have to have this immutability feature, but we have to see if anything serious which is captured in that particular, in that history or not. If anything serious, which will degrade that countries or societies that reputation, which will violate the law of the land, then always it is better to look at that particular history, and if provision exists, then if we can change that history without disturbing subsequent blocks, because disturbing subsequent blocks will demand a large resource requirement, time, computation, space, consensus, bringing all participants on board. So that is impractical. So if we can change some previous state without disturbing all subsequent state, if technically that is going to be done, then it is worth doing so. Okay, and that basically brings the that other direction of blockchain technology, which is popular in research scientific community, that is reductable blockchain. Whether reduction is required, if reduction is required, can we do so without disturbing all subsequent blocks where we want to redact that particular block or we want to redact that particular transaction. So that is that introduced reductable blockchain. So I am coming to that reductable blockchain part. Then authenticity, yes, it is required. Availability, it is required, and it is very, very demanding feature. And blockchain, that technology may provide this feature in a stronger way. Then finally we have to see practically. So this, that bold-faced text, integrity or immutability and practicality. So we have to basically negotiate with these two. If we say that okay, Bitcoin, that immutability must be there in all blockchain, then that may not be practical in different applications, right? So let me come straight to that fact where it is not practical, where we need a relaxed version of immutability, a reduction or reductable blockchain is more practical than the classical blockchain. Now question here is append only or immutability? If append only ledger practical for all context? My answer to this question is no. It is not practical for all applications. It is very, very practical for cryptocurrencies, similar applications, but it may not be practical for all applications. Consensus is required, transparency is required. But question that we should ask, why to make that transparency in public? Why to make it public? What would happen for privacy issues? Right? So if required, then we can have this transparency and we can have this ledger in public knowledge. But if it is not that required, that depends on the application, kind of application. Right? Suppose healthcare, you want important applications. Then say supply chain, another important applications. We need to basically have enter audience or public to say whether this is correct or incorrect, and that will basically disclose, leak the privacy issues of a particular individual or a particular record. Now, if it is required, then let us go with that public DLT, distributed ledger technology. If it is not, then we can have it in the form of private, which will be beneficial to that particular organization. Organization is running the enterprise with classical database concept. Now we can upgrade that enterprise from classical database to this distributed database. To earn more revenue, is going to provide more efficiency to customers. That is the takeaway from this blockchain technology. We cannot just fit same thing to one time, because that enterprise application, that organization is looking for customer convenience. Organization is looking for more revenue generation. Organization is looking for an efficient way to provide service. An organization is looking for security, privacy, that protection of asset from malicious people. And if we can bring blockchain technology into the context, and if we can enhance that enterprise of that particular organization, which is powered by blockchain, that is perfectly all right. And that organization can consider that blockchain as a private blockchain, as a consortium blockchain. But organization may not make that blockchain as a public. So based on that context application, that whether it is public, it is private, or it is consortium, or it is hybrid, that has to be debated, and finally that call needs to be taken. Immutability is required, but nothing is perfect. So I can do mistake, you can do mistake, and who is executing the transaction, who is rolling out that consensus, may be biased, may have some intention, may have some power, may have some money, more money, may have more space, right? So things may go in a wrong way also, because nothing is fully perfect. Human errors should be accounted for. Illegal documents should be removed, right? For example, if you are aware, I believe if people are aware about that GDPR, that privacy related discussions. European countries are very, very strong in that GDPR data privacy regulation, general data privacy regulation, so GDPR. Suppose one content, privacy related content, is already there in history, and people start blackmailing the owner of that content, then you see there is a problem, right? So if people start blackmailing the owner of that content, then best way is that let that content be removed from that ledger. Let that owner has right to forget about the content. So right to be forgotten, then that rewriting of that history, removing illegal documents from that history, because if that document is against of a particular country, then that country will not buy whether this blockchain technology is a very powerful, very successful, very important. That country is that foremost important, land of the law is foremost important than anything else. So that document needs to be removed from that ledger. Okay. Now there may be some error, there may be some malicious or biasness, there may be illegal content in the history. It depends on the particular kind of application. So in that case, immutability, strong immutability may not be practical. A relaxed immutability or controlled that correction, controlled immutability is rather practical for certain contexts. So what is that? The drawback of append-only ledger? Append-only ledger, for example, Bitcoin blockchain can be abused by storing arbitrary messages like privacy violated content. Users will stop downloading the blockchain on their computers with fear that they will be prosecuted for possession of illegal or improper content. So if blackmailing is there based on that append-only ledger, and if that blackmail is going in favor of a particular individual, a particular group, or some that top authority, then that should be stopped. Remove that content from the history, or rewrite the content from the history, or let owner of the content forget that particular. Okay, so then what we need in place of that classical blockchain, controlled rewrite ledger. Again, this is data structure. Append only is fine. It can work for Bitcoin cryptocurrency, but it may not be practical for all other applications. Controlled rewrite ledger. So this controlled is important, that keyword. It cannot be that flexible rewrite ledger. Anyone cannot be allowed to rewrite or modify. Controlled. Control means who is the owner, or who are the owners. Not is the owner, who are the owner, or who have authority to unlock that lock. Lock means that has collision, that is the lock. So if I unlock, so I can find a collision on other message, then I have a key. So here the top authority who can control that append only ledger by bringing this rewrite or mutable feature based on that application requirement. When that demand arises, then only the authority will come into picture, and it can redo the things without disturbing the subsequent blocks. That is known as controlled rewrite ledger or redactable blockchain. That blockchain will allow to redact in some previous states. Records can be updated in case they contain errors, or when it is required for larger interest for the law of the land. In that case, consolidation is hard to achieve with immutable blockchain. So we cannot do this by adopting that immutable blockchain. So what is that practical requirement and technical solution? There will be a provision in that immutability feature, so I can mute that using a particular key, and that key must be available with some trusted authorities who will come into picture to unlock, then redo the things, rewrite, modify, then it will again lock without disturbing any subsequent blocks. Subsequent blocks are going to be as it is. Only I have to find a collision on some modified content. And if I find a collision, then my job is done. And how I can find a collision? Not using the same SHA-256, using another pseudorandom function where that key is important. And using that key, I can find a collision. Without key, no one can find any collision. Now, controlled rewrite ledger should be decentralized. It should be decentralized, and it should follow distributed ledger technology. It may not be distributed, that distributed database, but it must be decentralized, and it should follow distributed ledger technology. So distributed ledger technology, you have a copy of the blockchain, but decision must be taken collectively. One person cannot take the decision. So for that, decentralization is important. So that controlled rewrite ledger should be decentralized and should follow distributed ledger technology. irrespective of permission or permissionless blockchain. Only trusted actor or trusted actors acting on agreed rules of governments can edit, rewrite, or remove blocks without breaking the chain, without disturbing subsequent blocks. Now you see in 2017, this group, Atenis and his team, that introduced this. After that, you will find, say, more than dozens seminal concepts came into light on blockchain technology, and people are basically contributing in that domain, so it can make application more and more practical. So any combination of these, rewrite one or more blocks. If I can rewrite one block, I will be able to rewrite more blocks. Compressing any number of blocks into a smaller number of blocks, inserting one or more blocks. So it basically, it brings the feature of full power of any conventional data structure, that add, delete, modify. All features will come into that structure, but in a controlled way. And that controlled way means who has that unlock key, who has an unlock as well as lock key. So reductions can be made only by authorized entities and under specific constraints. When that demand arises by country, by that agency, top agency, or by that authority, then only that authorized entities will be able to unlock, will find a modified content where that collision will be arrived at, and it can replace that existing stuff by that altered stuff, and that will not disturb the subsequent block. Reductions are publicly auditable by existing miners, so consensus should be there, and they will be on board while doing this reduction. So from this diagram, you can see that first line, it was that conventional blockchain. So lock has that hash pointer done, then this block again hash pointer with this collision, then again collision. So this is the conventional. The next two blocks, that reduction, reductable blockchain. So this block BI, suppose I want to modify some content here, okay, then I have to unlock. Unlock here means I have to find a message where collision, suppose this message was M, the previous BI message was M. Now I have to find a message M prime such that that hash of M equals to hash of M prime. Then collision is found. Now if I find the collision, in place of M, I can put M prime. And hash of M equals to hash of M prime. Then you see this BI minus 1, that block is not going to be changed because this is basically hash of M, and that hash of M is hash of M prime. Now that BI plus 1 is as it is, and I can unlock, I can find a collision on another message, replace previous old message by new message, then again I can lock this, and this is done. It will not disturb the subsequent blocks. And this hash or collision will not be obtained with that conventional or that SHA-256. It will be done with other cryptographic primitive. So reductable blockchain, edit block. So now I can do this. If I can reduct the blockchain, so I can replace this B2 by this new B2. And here I will find a collision. In place of B2, a new B2, then hash of B2 equals to hash of new B2. Then I can replace that. Then B3, B4, B5, B6, they are not going to be changed. That edit is allowed. Delete is also allowed. I can delete B3. Then I have to find a collision, that collision of B1 that hash of B1 should be same as hash of B1 will be same as B4. I can have that part. Then I can remove B3 from that existing part, or B2 is removed here. I can remove B2, then this will also work. So add, edit or modify, then delete. Now who can play a role in this picture? That a different kind of hash function or pseudo-random function. So previous case, this was the thumb rule, that gx equals to gx dash. So we will not allow. So we want a hash function which is collision resistant, like SHA-256. But that will not work for this kind of reduction context. So that will not work. So we will not buy that kind of hash algorithm in this particular context. So we will bring some other function such that gx equals to gx prime, and that will be observed based on lock key and unlock key, and this lock key unlock key will be available with that trusted authorities who are allowed to perform that reduction based on the requirement. The chameleon hash function is introduced by that attorneys group. It is basically a hash function is a trapdoor collision resistant function. The trapdoor is a new keyword here. Trapdoor collision resistant hash function. Without knowledge of the trapdoor information, a chameleon hash function has the same characteristics of any cryptographic hash function, such as pre-image collision resistance can be achieved. However, collision can be computed once the trapdoor is known. The trapdoor key is the pivotal parameter in this chameleon hash function. Person or authority who knows the trapdoor can find a collision. Otherwise, if we remove trapdoor, then this chameleon hash function will become a cryptographic hash function. Now, let me give you one template of this new primitive that has algorithm which will provide us controlled or reductable blockchain. So there are 4 sub algorithms, that has key generation, then hash generation, then hash verification, and finding collision for that hash. Now hash key generation, again this algorithm will take a security parameter and it will output one hash key and one trapdoor secret, the TK. Then hash generation on a message, so that will be done. It will basically give us 2 parameters, hash value of the message and that verification of that is jet, that is the verifier. Okay. Now check string, jet or verifier, that is the hash computation, and hash verification, again one can verify. It takes message M, hash value is, check string jet, and it outputs a bit. Whether verification is successful, then output is 1. If verification is not successful, then output is 0. Then important part is that hash collision, when I can find a collision. So for that, the TK, secret trapdoor key, is required. That is going as an input, and using that trapdoor, one can find collision on 2 messages. So here is one message M, then this verification H and Z. On another message M0, again another hash pair H and Z0. So I can find a collision on another message M0 with the help of the trapdoor key TK. If so, assume that M was there in the history. I want to modify M by another string, that is M0. I can do that. Or I want to delete something, then I can find some other message where this collision is obtained, and this collision is going to be obtained with the help of that trapdoor secret key TK. Okay, with that template, so there is this is that chameleon hash function, but later people found that this will not be secure. Then enhanced chameleon hash function or ECH is there. There are several other primitives came into light in that 3.5 years or 4 years from this introduction of this reductible blockchain. So there are several primitives: hash based, public key based, voting based. Then different primitives are available by which the reductible blockchain can be considered for different applications. Okay. So opportunities and challenges. Opportunities where controlled rewritable ledger is a practical use case we should not ignore. We cannot buy just one template, that immutable blockchain, which may not fit to all different applications. But different applications may need different kind of different set of requirements, and to fulfill different set of requirements, we may think of using that reductible blockchain or controlled rewritable ledger. Bitcoin has its own success story. However, some more novelty in blockchain structure, for example, reductibility feature, could make the structure equipped with more practicality as per applications without affecting the essential features of blockchain. We will have those essential features: consensus, transparency, and immutability. But this immutability is relaxed based on a larger interest of our society, based on larger interest of country, larger interest of that particular application service provider, or based on larger interest of the customers. So that may be relaxed in a controlled manner. Challenges: more novel primitives should be there in near future, which can make that controlled rewritable blockchain more secure, more meaningful, and practical. So cryptographic primitives existing as well as new primitives can make reductibility feature in blockchain practical and secure. Enhanced chameleon has secret sharing, multi-party computing can play important role in this context. So same trapdoor key can be shared among different people. So one party will not have the full power of that trapdoor key. So one can share that same trapdoor among, say, 3 parties, and out of 3, any 2 parties can unlock, any 2 parties can lock. But one party will not be allowed to unlock or lock. Something like that. Okay, let me summarize this discussion. What we have discussed in this session, that finding a scope of controlled rewritable blockchain in different applications, and classic blockchain technology can follow as it is wherever it can find scope and applications. But in addition to this, we can also find that controlled rewritable ledger feature in different other applications where a reduction is required, and for that reductibility feature, so we can bring other cryptographic stuff into the picture. So blockchain technology has found enormous applications in many areas, many domains. There is no doubt in it, and depending on context, blockchain enabled application may accommodate human errors, legal and regulatory requirements. Controlled rewrite ledger is a prominent area of exposure for further research in blockchain technology and its application. So I would give this to all audience. So in addition to that, Bitcoin, Ripple, Ethereum, and different that consensus protocols, algorithms, different platforms, you also think of contributing in a say in a different way, bringing some novel ideas into this controlled rewrite distributed ledger technology or reductable blockchain, that topic or that term. Okay, with this, I'll stop here. And for more about my research, my group research, you can visit to that research group, as well as this is the URL of homepage. You can find all other information, and you can reach out to me for any questions, any discussions, or any other information. I'll stop here, and now I would expect some questions from audience. I have say at least 5 minutes time.
There are a few questions in the chat box already, sir.
Okay, I'm just stopping this. I'll stop this. Stop sharing. Chat box. Okay. Is it? Let me go to different consensus. I think I have explained a bit. Do we have to select the consensus algorithm based on application? Yeah, it depends on that application. Hyperledger, Ethereum, so different platform you can use, and that on application you see which will basically have best fit. Then finally you have to carry on these three essential features, and who are the participants? They have to basically agree on that consensus algorithm. How can we maintain the privacy of sensitive data as blockchain is transparent to everyone? I think I have mentioned briefly that why to make it public. So you can make it hybrid or private if it is not that appropriate to make each and every blockchain as public blockchain, because privacy sensitive informations are very critical. I gave one context, that healthcare application. So privacy as well as that sensitivity of data must be preserved. For that transparency, you have to control within your that closed group. You may not make that ledger publicly accessible, even though publicly accessible for verification. But for other feature, you can control that. With respect to privacy and security, which blockchain is good choice, Ethereum or Hyperledger? Both are equally good. So I cannot give my vote to anyone. So Hyperledger is a very powerful and basically endorsed by industry giants, and it has many interesting features. You can accommodate different blockchains in that platform, Hyperledger. Ethereum, it has merits. You can go with Ethereum also. And important thing is that you first ask question whether your that blockchain that is going to provide any incentive, any reward. If there is any incentive, any reward, then you can simply adopt Bitcoin, because that is very successful, that incentive model. You can consider Bitcoin. Or if there is reward or incentive, you can accommodate Ethereum in that case. Okay, but if that is not the case, you are not going to give any reward, you are not going to have any incentive model, you want to basically enhance the features, efficiency, transparency, then availability, security. You want to enhance the feature of your applications, you have to make it customer convenience. Then Hyperledger would be very good choice for that. But it depends. I'll give it to you back. I am fine with both, including Bitcoin also. Okay, and it is a choice. You can go by Hyperledger because that is being promoted by the strong industry that pool, and many that new top up or new features will be added in near future, so that can be adopted for different applications. But if your application is going to have incentive model, then you can simply just consider Bitcoin or Ethereum or similar. I don't see any other question. If you have any other question, you can ask me now.
Yes, sir. I'm having one question. In you listed, I'm talking about the normal, this conventional blockchain, sir, not the redactable. So in one of the myths, you told that it can be hacked. But as per the definition, that a blockchain is tamper-proof. That every block is immutable. So hacked means it can be read, but it cannot be tampered.
No, that I got that point. That hack means it is that person is not going to alter that history.
It's tamper-proof.
Yeah, it is that is not possible. So that is mathematically proven fact. It is not going to be done because that will demand more resource, and that hacker will not have that much resource.
Yes.
So a hack means that whether it is secure. Suppose you are using one wallet from my that service, that some wallet of that blockchain, right? And if hacker is able to access your wallet, if hacker is getting all the coins available in your wallet, then hacker will be able to utilize that wallet on behalf of you.
Yes.
Then you will lose the money, that different coins. That Bitcoin also, that DAO, if you are aware, that DAO, that distributed autonomous organization, that DAO, that insider theft of say millions dollar Bitcoin was a very very known fact. Then Mt. Gox, another hacked that say more than 700 million euro, again Bitcoin, that stolen by hacker. So it is basically a distributed ledger, and people are having their own wallet. And if that wallet is soft wallet, and if that wallet is under control of hacker or attacker, then ultimately you are going to lose money. So you believe that your wallet is secure. Today you have, say, suppose number of Bitcoins today, but tomorrow you will see that your wallet is empty.
Yes.
That is the security of that, whether it is secure or not secure. And that hacked means it will be under control of the hacker, but hacker is not going to modify the history, or hacker is not going to that tamper any previous transaction.
And another question, sir, in the case of redactable blockchain, so you can alter or delete the blocks, and everything relies around hash collisions, finding out the collisions.
Correct.
Now my question is, suppose in one block I want to alter the data. The new message may not result into the collisions. So how actually this works? So it is very little difficult for me to comprehend.
So I'm giving you that. Suppose you know that, okay, there are some error, there are some keyword or some message which is not appropriate, and you have to alter that. Okay. Now you have a key, that secret key. Now left hand side you have that previous message M. Right hand side you bring a new message, such that both sides will give you same value, digest. So you left hand side you have that existing message, and you have to change that message. You have to tweak that message with the right-hand side message, and right-hand side message you start populating. So it can be one word, it can be 2 words, it can be 3 words. So right-hand side, you replace a message with the help of that secret key, such that both left-hand side and right-hand side will give you the same value. Then you find a collision. And technically, it will be done with the help of that chameleon hash function, enhanced chameleon hash function, secret coin, public coin, and other primitives are there. With that, you have to basically keep adding that number of words, and finally it will give you the same message, the same digest value. If you look at that chameleon hash function or enhanced chameleon hash function, then from that you will get some other primitives which are available in literature. And technically, mathematically, you can see that, okay, how it is easy. But that easy is possible with the help of that trapdoor key. Without trapdoor key, it is practically infeasible.
Yes. Thank you, sir.
If no other questions, then I am done. So thank you all for listening to my session. And if you have got some ideas from this session, then my takeaway, my job is done. Otherwise, in near future or whenever you want something new in this area or in the area of cyber security, check my homepage where you can get all my contact details and my research group. So most welcome with your ideas and with your that suggestions in near future. Thank you all.
Thank you very much, sir. I thank Dr. Manik Lal Das for providing various perspectives to blockchain and redactable blockchain, giving insights into the issues and opportunities of blockchain and redactable blockchain. Thank you very much for getting associated with this FTP and sharing your valuable knowledge, sir. We look forward to more such associations with you. Thank you very much, sir.
Thank you all. I'm closing this session now, if you permit.
Yes. Thank you very much, sir. Thank you.
Okay. Okay. Bye. Bye.
Bye, sir. Thank you.